All right, guys, we're doing 29-4, day 3. You guys should be experts at this. You could probably teach this now. You might not even need to watch this video, but hey, you can maybe try it on your own first. So here we are again, trying to graph this without a calculator. We need to find these 5 things and go from there. So let's start by simplifying this expression into a single fraction. They have different denominators. Let's get them to be the same. Let's multiply this one by this denominator, x minus 1. Multiply the second fraction by this denominator, x plus 1. Okay, that looks a little messy, so let's simplify. Let's distribute the top. And now our denominators don't need to be distributed. They just need to look alike. The numerators have to get distributed because we're going to try to combine them into one fraction. So let's do that, and it looks like this. Nothing cancels, no common factors on top and bottom, so it's simplified to this. There are no holes. My vertical asymptotes, the x's that I cannot have, are 1 and -1. So let's go ahead and plot those. What about horizontal asymptotes? You're looking at the degree, which is the power of the numerator, x to the first, and the power of the denominator in standard form would be x squared. So the denominator is larger, which is pretty common. So if that happens, y equals 0. Make sure you're writing it as an equation. It's a line, just like your vertical asymptote is a line. Okay, that's 3 of the important pieces. Let's find x and y intercepts. To find the x-intercept, plug in 0 for y, y-intercept, plug in 0 for x. Nothing new here. Here's my work for you to check. Then I'm going to write those up above and plot those. X equals 0, y equals 0. So on the x-axis, x equals 0. On the y-axis, y equals 0. Well, that's the same point, which makes sense because it's the intersection of the two. Now we only have 1 point here, so how in the world am I going to make a graph? Well, this is where you don't need a calculator, but, we're going to plug in 10 and -10. I like to start with 10 just because I'd rather plug in a positive number first just to get comfortable. So I'm going to plug in 10. I would plug it into this simplified version here. So without a calculator, 2 times 10 is 20, and then my denominator, if I plug a 10 in here, 10 minus 1 is 9, 10 plus 1 is 11, so I get 20 at the top, 9 times 11 at the bottom, which is 99. Even if these numbers were larger and I had a hard time multiplying them, that's fine. 20 over 99, I know is a very small number, less than 1, but still positive, still above 0. So over here at 10, I'm going to be slightly above the axis, about right there. Now let's plug in -10, again to the simplified version. So the numerator is going to be -20. The denominator is going to be -11 and -9 multiplied together, which we know is a negative and a negative is going to be positive 99. So this ends up being -20 over 99. By the way, these are not always going to be the same with one positive, one negative, just the way it works out this time. So over here at -10, I'm going to be slightly below, slightly in the negative region, but not very far. That's actually all the information I need to see off to the left for your work part. And then for the graph, how will I graph this? So the big question is this going to go down, or is it going to go up? What do you think? Well, if it goes up, do you see how I just crossed the x-axis? And it's not going to. It only crosses the x-intercept right here. So that means it has to hit that red point there, and it cannot hit this x-axis anymore, so it's going to go down. Okay, I don't always go in order. Let's do this section over here. Kind of the same idea. I know it's going to go out here, getting close to 0. It's not really going to go up. It's just hard to draw. Am I going to go down or am I going to go up? Well, I can't go down. So if I go down, I'm going to have another x-intercept, just like I mentioned over there. So it's going to go up. If you're not sure, you can always plug in 4 to this over here and see what you get. You could plug in 3 and see what you get. You can plot more points if you want, but you don't have to. I would just do negative 10 and 10. Now this section over here, we don't have repeated roots. That's when I put the star by it. So what's going to happen is on this asymptote, this one right here, to the left of it, I'm going down forever, which means to the right of it, I'm going to be going up forever to positive infinity. And over here, this is going up. So on the opposite side of this asymptote, we got to do the opposite. We got to go down forever. So connect those with that dot. And you can always check I would type in the original, carefully type it, into your calculator's y equals to check your graph. It shouldn't be quite curvy like this. It should go kind of like the x cubed function, but flipped. So there's your graph. Go ahead and work on your homework.